Hello, what happened to the person who stole a calendar? Got 12 months. All right, straight to it. This is where it gets a little bit more practical. When I say practical, I mean it's a little bit of just a formula, but we're going to learn how to differentiate exponential functions. Okay, we've learned how to graph them. And so that's what we're going to start. I hope you remember how to graphically derive. So we need to look at the gradient, the gradient of the tangent. So as you can see, if I was to draw tangents up in here, all the gradients of these tangents are actually positive, but you can see as it goes on, it gets steeper and steeper and steeper. Okay, so all these tangents are positive and they're getting steeper and steeper, which means our gradient function is actually going to look very similar. We're going to start small, but it's still positive. And then as we get further and further on, it gets steeper and steeper. So from here, we can actually see that the derivative of e to the x is just going to be another e to the x. Okay, now let's examine some common formulas that you'll see. All right, some rules, just like we do have for differentiation. Okay, I'm going to start with the left-hand side, and then the right-hand side will be some examples. So the first one is if I have y equals e to the x, we saw from before, your y dash becomes e to the x. Okay, don't stress it. Differentiation is not effective against exponentials. Okay, especially when they're kind of plain and simple, nothing really changes. Don't forget, the derivative of an exponential will be an exponential. So if I look at this one here, the only difference is I've got this constant out front. Constants do not change my derivative much. So in this particular case, that 5 is just going to stay there because when I differentiate the exponential, guess what I get? An exponential. And so there you go. Derivative of 5e to the x is 5e to the x. Now, what happens if we've got something a little bit more intense like this? I've got some sort of e to some sort of coefficient of x plus a constant. What happens here is your derivative is going to be whatever the coefficient of x was multiplied by our original function. Okay, I know this looks gross. It'll make a lot more sense when we look at the last one. Similarly, that means here's our coefficient. That's our a. That comes down to the front. And then we multiply it with our original. Now, sometimes I'll put a dot in there. This dot essentially means multiply. So it's not a decimal place, it's just multiply. You'll see it a lot in I guess, maths coming up. It just kind of helps with the visual representation. All right, now this is the one that you're going to get in your reference sheet. If I have e to some sort of function of x, kind of like this guy here, but this one's just a more generalized version. What you get is the derivative of fx, and then you multiply it by the original, which is just e to fx. Okay, that allows us to do these kind of more complicated ones where I've got some sort of fancy function. So to find my derivative, all I need to do is find the derivative of my function. So I can see here that would be 4x, take away 6. There's my f dash x. And then what do? Times it by the original, times e to the 2x squared minus 6x plus 7. And I would leave your answer just like that. One last one that I will touch on is there's also a rule when we start to differentiate exponentials that don't have a base of e. As you can see here, all of these ones are e. These are the rules for that. Okay, in your reference sheet, you get this little formula here. Let me highlight it for you or square it. If I have anything that is not a base of e, so here we can see a is clearly not e. So if I have a to some sort of function, the way my derivative works is I have ln of a multiplied by the derivative of the function multiplied by the original function. So it's essentially the same thing, except for that ln a. Okay, let me show you what that looks like practically. if I was given a function y equals to 7 to the power of 2x, my y dash would be, first I'll start with the ln a, and ln of my base would be 7. And then I've got f dash x. So if that's that, my derivative of 2x is 2. And then I need to multiply it by my original function, which is just going to be 7 to the 2x. Now, as much as you attempted to multiply these two together, do not, because that 7 has its own power. It's in its own league. Okay, the best that you can really do here, really struggling with these colors here, just 2 ln 7 times 7 to the 2x. That is as good as you're going to do here. Hopefully that helps. Good luck differentiating. Have fun and see you later. Okay, bye.